In this lesson, we are going to talk about the x-intercept form of a quadratic relation. Remember, the x-intercept of a quadratic relation is given by y equal a times x minus r times x minus s, where r and s are the zeros or x-intercepts of a quadratic. Now, we also saw in previous lessons how to find or how to convert a quadratic equation to factor form. Now, we know to change it to a factor form, the first step is to do common factoring, and then if the leading coefficient a is equal to 1, then we use sum and product. If it is not equal to 1, then we have to use decomposition method. Now, to find the zeros, when you find the quadratic equation in factored form, we are going to make it equal to 0 to find the x-intercepts, meaning we have to solve a times x minus r times x minus s equal to 0. When the product of three numbers, a, then this bracket and this bracket is equal to 0, then it means at least one of them has to be 0. This means either a is 0, but we know that a cannot be 0, so x minus r has to be 0, or x minus s has to be 0. When you solve this one, x is equal to r. When you solve this one, x is equal to s. So you can see why we say r and s are the zeros or x-intercepts of quadratic. What it means is that if you have a quadratic equation either in vertex form, standard form, or intercept form, they all are going to be graphed the same, meaning the graph of the three equation is going to be the same. It's going to be different forms of equations, but the graph is exactly the same. Let's start with an example. Y equal 4x squared plus 4x minus 168. We are supposed to graph this one. To graph this equation, we are going to find the x-intercepts, the y-intercept, and the coordinate of the vertex. Then we are going to plot the points. To find the vertex, we know that the x-coordinate of the vertex, v sub x, is equal to minus b over 2a. Now in this equation, b is negative 4, this one. So b is negative 4. Minus b is negative 4. 2a is 2 times 4, which is going to be minus 4 over 8, which is negative 0.5. Now to find the y-coordinate, we have to sub negative 0.5 in the equation. So v sub y is 4 times negative 0.5 squared plus 4 times negative 0.5 minus 168. If you evaluate this one, then we are going to get negative 169. So we know the vertex is at negative 0.5 and negative 169. That's the vertex. The second one, we are going to find the y-intercept. The y-intercept is when x is equal to 0. So let's evaluate y when x is 0. So we get 4 times 0 squared is 0, plus 4 times 0 is 0, minus 168. So the y-intercept is the constant, which is minus 168. Now the only thing you have to find is the x-intercept. To do that one, we are going to try the factoring. See, hopefully it's going to work. The first step is common factors. So we can write 4, y is equal to, we take 4 out, we get x squared plus x minus 168 divided by 4 is going to give us 42. Now we have to find two numbers. Product is 42, add up to 1. Let's write down those pairs. 142 is one of them. The other one is 221. Next one is 6 and 7. And 14 and 3. Now between these pairs we have to find one which the sum is going to be 1, because b is equal to 1 here, and the product is negative 42. So one of them has to be positive, the other one negative. The only one which is possible is that if 6 is really negative 6 and 7 is positive 7, because 7 minus 6 gives us 1. So we can write this one as 4x minus 6 x plus 7. Now to find the x-intercept, we make this one equal to 0. The only possibility is either 4 is 0, which is impossible, or this is 0, or this is 0. If x minus 6 is 0, from here I get x is equal to 6. It's one x-intercept. Or x plus 7 is equal to 0, which gives us x is equal to negative 7. So the x-intercepts are 6 and negative 7. The y-intercept is negative 188, and the vertex is equal to negative 0.5 and minus 169. Now, let's go ahead and plot these points. We are going to renumber these. This, I'm going to make this one 50, 100, so this is 100, this is 150, and this is 200, and this is 50. These on the x-axis, I'm going to leave it the same way it is. So the first point I'm going to plot is a vertex. When x is negative 0.5, which is here, y is negative 169. Remember, this is negative 50, this is negative 100, negative 150, negative 200. So negative 168 is very close to here, and negative 0.5. So this is going to be my vertex. Now the y-intercept is negative 168. So it's going to be very close to this point here. My x-intercept is 6, which is here, and the other one is negative 7, which is here. So we just connect them with a smooth curve. So it's going to be something like this. And if you recall, your a value is 4, which is positive, so the parabola opens upward, which is exactly what we have here. In the next example, we are going to graph y equal negative 3x squared plus 24x minus 48. The first thing is the y-intercept. We know the y-intercept is the constant here, which is negative 48. So the y-intercept is negative 48. Remember, it's only in y-intercept that we say the constant for negative 48. If it's another form like factored form or vertex form, then you have to manually put x equal to 0 and find the value of y. So don't make a mistake. Whenever you see the constant, you say that's a y-intercept. The next one I'm going to find is the vertex. To find the vertex, I know that v sub x, which is the x-coordinate of the vertex, is minus b, which is negative 24, divided by 2a, which is 2 times negative 3. So it's negative 24 divided by negative 6, which is going to give me 4. So the vertex, the x-coordinate is 4. Now the y-coordinate, I put it back in the equation and find y. So I'm going to say v sub y is negative 3, 4x1 and 2, plus 24 times 4 minus 48. If you simplify this one, then you are going to find that the y-coordinate of the vertex is 0. So this means that point 4 and 0 is the vertex. Now to find the x-coordinate of the vertex, the x-coordinates of the zeros or the y-intercepts, we have to factor out the equation. To do that one, I know that the common factor is negative 3. So I can write this one as y is equal to negative 3, open bracket. Negative 3x squared divided by negative 3 gives me x squared. 24 divided by negative 3 gives me negative 8x. And negative 48 divided by negative 3 gives me 16. Now, since the leading coefficient is 1, I can use sum and product. I have to find two numbers that the product is 16. Those two numbers are 1 and 16, 2 and 8, 4 and 4, and that's it. Now, also the sum has to be negative 8. So this means that out of these pairs, the bigger number has to be negative and the smaller has to be positive, and the sum has to be negative 8. The only one which is possible is going to be 4 and 4, if both of them are negative. Negative 4 times negative 4 gives me 16, and negative 4 plus negative 4 gives me negative 8. So this one I can write as negative 3 x minus 4 times x minus 4. To find the x-intercept, I make this one equal to 0. Negative 3 can't be 0, so x minus 4 is 0. And again, x minus 4 is equal to 0, the second term. This gives me x is equal to 4. This gives me x is equal to 4. So I know that the x-intercepts is only 1 point, x is equal to 4. Now I have enough information and I can go ahead and plot the quadratic. To do this one, the first thing is that I know that the x-intercept is 4. So this is going to be my x-intercept. The vertex is also 4 and 0. This is the vertex. So this means that the vertex and the x-intercepts, they are on top of each other, which is this point. Now, the other point I have is the y-intercept is negative 48. So I'm going to change the numbering. I'm going to say this is negative 10, this is negative 20, and this is negative 40, this is negative 50. So negative 48 is going to be somewhere around here. So I'm going to connect these 2 points together with a smooth curve up to here. Now to find the next point, which is to the right of the vertex form here, I'm going to use the property that the line which goes through the vertex is the line of symmetry. Now, if this is the point to the left, if I go to the right the same amount, I'm going to hit the second point. Now, this distance is going to be 4. So I have to go 4 points to the right. So I get to x is equal to 8, and the y value is going to be negative 48, which is going to be somewhere around here. So my curve to the right becomes like this. So this is going to be the graph of y equal negative 3x squared plus 24x minus 48. The next example is to plot y equal x squared minus 8x. Again, this is a standard form. I can see that the constant is 0, so I can say that the y-intercept is equal to 0. Now to find the x-intercept, I'm going to change it to factored form. So I'm going to factor out x here. I get x minus 8. I make this one equal to 0. There are two possibilities. Either this is 0 or this is 0. The first one gives me x equal to 0. The second one gives me x minus 8 is equal to 0. So x is equal to 8. So the x-intercepts are 0 and 8. The next one, I have to find the coordinate of the vertex. I know the x-coordinate of the vertex is minus b, which is minus 8 over 2a, which is 2 times 1, which is 8 over 2, which is 4. Now to find the y-coordinate, I put this one back and I get 4 squared minus 8 times 4, which is 16 minus 32, which is equal to 16. So the vertex is going to be 4 and minus 16. I made a mistake here. 16 minus 32 is minus 16. So I have these 3 points, enough to plot the graph. The first one is the y-intercept is 0. So this is my y-intercept. The second one, x-intercepts are 0, which is the same as y-intercept, and also 8, which is here. And the next one is the vertex, which is 4 and negative 6. So 4, negative 16. Now, our graph is not big enough to do that one, so I'm going to change this one to negative 10, this one to negative 20. So negative 16 is a little bit, so it's going to be somewhere around here. This is going to be the vertex. Now I'm going to connect these points together, and I'm going to get a parabola that looks like this. The next example asks us to plot y equal x squared plus 3x plus 20. The first thing we notice is that the constant here, which is the y-intercept, so y-intercept is going to be 20. Again, y-intercept is the constant if the quadratic is in standard form. The second thing I have to do is I have to find the coordinate of the vertex. I know that v sub x, x-coordinate of the vertex, is equal to minus b, negative 3 over 2a, which is 2, which is negative 1.5. To find the y-coordinate, I sub this one back in the equation, so I get negative 1.5 squared plus 3 times negative 1.5 plus 20. If you simplify this one with your calculator, then you get negative 17.75. So the vertex is going to be at negative 1.5 and negative 17.75. Now I have to go ahead and find the x-intercepts. I'm going to use factoring technique first. Since the coefficient of x squared is 1, I'm going to use sum and product. I have to find two numbers that the product is 20. Those two numbers are either 120, 2, 10, 4, 5, and 5, 4. So we're going to stop right here. Now, the sum of the two numbers has to be 3. 1 and 20 is 21. 2 and 10 is 12. 4 and 5 is 9. you can see that the sum cannot be equal to 3. This means that the factoring technique does not work here. So the question is, how are we going to find the x-intercept if the quadratic is not factorable? In cases like this one, that the quadratic is not factorable, we have to use the quadratic formula. Because to find the x-intercepts, I have to find the solution to this equation is equal to 0. To find the zeros, I'm going to use the quadratic formula. I'm going to say the roots are minus b minus 3 plus or minus b squared, which is 3 squared, which is 9, minus 4ac, which is 4 times 20 times 1, divided by 2a, which is 2. This gives us negative 3 plus or minus square root of 4 times 20 is 80 times 1 is 80. So this one becomes 80. 9 minus 80 is negative 71. And by now you know that the square root of negative numbers does not exist. So this means that this one does not have any solution. So for x-intercept, we say none. There is no x-intercepts here. Let's plot and see how the graph looks like now. The y-intercept is 20. So let's renumber here. I'm going to multiply everything on the y-axis by 2. So this means that this one becomes 20, this becomes 16, this becomes 12, this becomes 8, and this becomes 4. So y-intercept is 20. So this is my y-intercept. I just noticed the mistake I made previously. The vertex, the y-coordinate is positive 17.75. The x-coordinate is still negative 1.5, but the y-coordinate of the vertex is positive 17.75. So let's plot this point. When x is negative 1.5, which is here somewhere, negative 1.5, y is 17.75, which is going to be, let's see, 16, 17, which is going to be somewhere around here. This is going to be our vertex. The x-intercept is none, so there is no x-intercept. Now I have the y-intercept and the vertex, so I can plot this part of the graph. To find the other part, meaning the left side, again I use the property that the line that goes through the vertex is the line of symmetry. So if the y-intercept is to the right 1.5 unit, if I go 1.5 unit to the left, I'm going to end up at negative 3. Then the y-coordinate of that point has to be exactly the same as the vertex, which is the y-intercept, the y-coordinate of the y-intercept, which is 20. So this means that the next point is going to be somewhere around here. So this is going to be my curve. It's a little bit hard to see, but this is the way we plot it. You always plot the y-intercept, the x-intercept, and the vertex, and then to find the other point, you use the property of the axis of symmetry to find the fourth point. The next equation that we have to plot is y equal 3 times x plus 4 squared minus 108. The first thing we notice is that the vertex has the coordinate -4 and -108. Remember, the formula is x minus h squared. Here is x plus 4, so h has to be -4. And -108 is the y coordinate. Now let's find the x-intercept. To find the x-intercept, we have to let this equation equal to 0. So 3 times x plus 4 squared minus 108 is equal to 0. Now we try to solve it. I bring -108 to the right. I get 3 times x plus 4 squared is 108. Now I divide by 3 both sides. I get x plus 4 squared is equal to 36. I take the square root of both sides. I get x plus 4 is equal to, now 36 square root is not 6, it's plus or minus 6. Because 6 squared is 36, -6 squared is also 36. So there are two solutions. Either I can go with plus 6, I show it with a plus here, or I can go with -6. If I use plus, I get x plus 4 is equal to 6. Move it to the right, I get x is equal to 6 minus 4, which is 2. The next one is x plus 4 is -6. If I move 4 to the right, it becomes negative, so -6 minus 6 minus 4 is -10. So the x-intercepts are 2 and -10. Now we are going to find the y-intercept. Remember, to find the y-intercept, x is equal to 0. This is not standard form, so I can't say that y-intercept is -108. I have to sub x equal to 0 and evaluate. So I'm going to say the y-intercept, y is 3 times 0 plus 4 squared minus 108, which is 3 times 4 squared is 16 minus 108. If you evaluate this one, you get -60. So the y-intercept is -60. Now we are going to go ahead and plot the graph. Now to plot the graph, we know that the vertex is -4 and -108. X-intercept is 2 and -10, and the y-intercept is -60. I have renumbered the y-axis by multiplying every previous unit by 10. So 2 becomes -20, 4 becomes -40, up to -100. Then I've added one other part to the graph, which is -110. The x-axis, I just leave it the way it is. So let's start plotting. Vertex is -4 and -108. So it's -4, so it's going to be somewhere around here. This is going to be my vertex. The x-intercepts are 2 and -10, which is here, and -10, which is here. And the y-intercept is -60, which is here. So I can plot a smooth curve going through the 2 points on the right of the vertex. Now on the left, I have one point, which is here. The other point, I'm going to use the property of the line that goes through the vertex, which is this line. Now the y-intercept is here, so I'm going to go to the left the same amount, which is 4 units. So if I go to the left of -4, I get -8, and then it's going to be -60, which is going to be this point. So the left curve is going to be something like this one. So this is going to be our quadratic. Now let's write the equation in standard form. This is the equation in vertex form, so to change it to standard form I'm going to write it as 3x plus 4 times x plus 4 minus 108. Now I'm going to distribute x inside the bracket. X times x is x squared. X times 4 gives me 4x. Now I'm going to distribute 4 inside. 4 times x gives me 4x. 4 times 4 gives me 16 minus 108. Now I distribute 3 inside. 3 times x squared is 3x squared plus. Now 4x plus 4x gives me 8x times 3 gives me 24x. And 3 times 16 gives me 48 minus 108. Now this gives me 3x squared plus 24x minus, and this one is 60. One interesting part is that if you look here, the constant is negative 60, which is the y-intercept, which is the same thing that we found here. So remember, the constant in standard form is always the y-intercept. In the next example, we have a football which is kicked from the ground. The path is given by the relationship h is equal to negative 4.9 t squared plus 22.54 t, where h is the ball's height above the ground and t is the time. The first question is write a relation in x-intercept form. To do that one, I have to change it to a factor. To factor this one, I can factor negative 4.9 and t, because both of them they have t, and I can divide 22.54 by negative 4.9. I get h is negative 4.9 t times negative 4.9 t squared divided by negative 4.9 t is going to give me t, and also 22.54 t divided by negative 4.9 t squared is going to give me negative 4.6. So this is the factored form. The next question says, use the intercept form of the relation, make a table of values with times from 0.5 to 3.5 in increments of 0.5. So this is going to be my table of values for t from 0.5, increment of 0.5. So it's going to be 2, 2.5, 3, and 3.5. And then I have to evaluate h for each one of these values. I'm going to show you just one of them and then you can do the rest. So for t equal to 0.5, I had to find h is negative 4.9 times 0.5, open bracket, t is 0.5 minus 4.6. Which is equal to 10.045. So this gives us 10.045. If you do the same thing for the rest, you get 17.64, 22.785, 25.48, 25.725, 23.52, and finally 18.865. The next part of the question says use the intercept form of the relation to find the zeros, or the x-intercepts. This is, as we found before, this is the factored form or the intercept form. We have to make this guy equal to 0. If this is 0, either this has to be 0 or this has to be 0. This means either t is equal to 0 or t minus 4.6 is equal to 0, so t is 4.6. This means the zeros are t equal to 0 and t equal to 4.6. The next part of the question wants us to plot the graph using the x-intercepts that we found. Remember, the x-intercepts are 0 and 4.6, and the table of values. I don't have the table of values here in front of you on the screen, but I do have it on the paper, and hopefully you do have it on the paper too, so we can plot it together. Now the x-intercepts are 0, which is this point, and also 4.6. I have renumbered everything here. So 4.6 is going to be somewhere around here. So these are my x-intercepts. Now the first point was 0.5 and y is equal about 10. 0.5 is y is equal to about 10, which is this point. 1, y is about 17.6. So 1 is, this is 15, 16, 17.6 is going to be somewhere around here. When x is 1.5, y is 22.785. 22.785, this is 25, so 22 is going to be somewhere around here. When x is 2, y is 25, about 25.48. So 25.48 is going to be around here. This is going to be the next point. When x is 2.5, y is 25.725, 2.5, 25.7, which is somewhere around here. When x is 3, y is 23.52. This means that the ball is coming toward the ground, so it's turning. So it's going to be 23, which is going to be around here. And the last, when x is 3.4, y is 18.8. 3.5 is 18, which is somewhere around here. Now I can connect all these points together. I can go like this, and then I can turn and then come like this. So the graph looks something like this. The next question says, when did the ball hit the ground? The ball hits the ground when the value of h is equal to 0. And if you remember, the x-intercepts were t is equal to 0 and t equal to 4.6. This means that the ball hits the ground initially, which is correct, and also 4.6 seconds after it was hit.